Oh. Hello? Test, test, test. Oh. All right. So, my name is Oscar Alvarez. I program in Fortran. I do research at the University of Texas at Arlington. I do computational fluid dynamics post-processing. So it's just you have a big vector field, just a big data file, and we process those vectors. And because our data is so big, Fortran is just the way to go here. Of course, I could use other languages, but a lot of legacy code was written in Fortran, and then I had to read Fortran to read the I had to learn Fortran to read the legacy code, and that's just where I am now. I use Fortran because it's really cool. Okay, so let's get started. This is my to-do list right here. This is what I'm going to do today. If you don't understand that, that's okay. I will not explain it to you. This is the current code that I have. This is my version 3 of the code. Oh, let me get pulled just in case. Just in case. What is this? What is this other one? Oh my god, y'all see my start button? I don't know if I'm allowed to cuss or anything on stream. I'm not really here to get monetized. I'm just kind of here to show my knowledge, share my knowledge, and hopefully get y'all interested in Fortran and maybe learn a few things. So here we go. I'm gonna pull the repository that I have. You have on-stage changes. Please commit and stash them. This is my favorite part. I love Git so much. So Git and Git commit. Let me Git commit. I have to rebase for some reason, and git pull. Okay, now git push. Okay, git pull again. Everything's up to date. All right, cool. I learned that yesterday. I have to push everything that I do, and then whatever. Anyways, so I have these batch files. Sorry if you can't read this. Text is the size it is. Could change it, but I don't want to. So I'm going to change this batch file. Actually, I need to make another one. And this is going to be for version 3. And this is just going to compile my code, because in Fortran, it's a compiled language. You have to compile it, and you also have to run it. So this file compiles my module for Fortran, which has all my functions, and it compiles my my program, and then it runs it together. So let me is this edit? Rename. Weird. Okay. So this is version 3. So all I have to do is change this to version 3 and we're good. Version 3, version 3. Save. Awesome. Let me open version 3. Let me see if it complains at me if I do that. Git commit. Created v3 bad file. Alright, so we're good. Alright, no worries about that. Now I can start working on this. I need to open my module because I think I'm going to be adding stuff to the module file. If not, I'm going to be using it. So this is the module file, has all my functions that I make. You can see I have a Hessian matrix function, a divergence function, a gradient function, cross product. If you don't know what these are, I'm not going to explain it to you, but they're just mathematical things with matrices, functions, and stuff like that. So my professor wants me to filter our vectors and data points using these using these conditions. So that's what this file's gonna do. I'm gonna have to delete a lot of things. I'm gonna have to add a lot of things. There, y'all probably can see that a little bit better. But okay, let's get started. I gotta do this. So the first thing I gotta do is this condition. That is this condition right here. The omega Leotex is greater than or equal to, and I have the tolerance right here. I don't like how I have omega L and L omega, so I'm going to make this omega L for consistency. And I got to change my variable up here. Where is it? Omega L. This is now good at, oh, that's omega L. The tolerance is right here. L omega. And I just split my workspace. I like to keep the variables up here and then my code down here. That way if I change any of the variable names, I could, or add a variable, I could easily just change it instead of scrolling up and down and up and down. Ugh, I don't like that. So that's my first condition. This is, yeah, so cool. Why is my ear itch? Ear itchy. Itchy ear. Bruh, okay. These have to be back to 1. And get rid of this. Okay, tolerance for omega Leotex. It's for dot product. And I need a tolerance for the divergence. Divergence. I'll just do dive tall equals 1D. That's the -6. So because of numerical errors, this is basically saying it's really, really close to 0. But because of numerical errors, some might not actually be 0. They might just be close to 0. So that's what this type, the tolerance is for when I do the divergence of this vector. I'll take the magnitude and it'll be close to 0, close enough, right? So that's why we're doing that. Okay, one of the things that I need to do is normalize everything because I'm going to delete all of this because I'm starting over essentially. Oof. I have to normalize every value. Yes. I have to make the vector and normalize it. So I'm gonna normalize everything here. I'll do this here. I'm gonna normalize vector fields, and I'm gonna normalize omega L. What was the point name? Or I have to do it for each of them. So this is going to be another one of these. This is a three-dimensional vectors, or three-dimensional, well, they're three-dimensional vectors, but also three-dimensional arrays. God damn it. Gosh darn it. I mean, gosh, ding dong, ding 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 ding, ching chong chong chong. That's also kind of racist, so I'm not going to do that anymore. Okay, so I'm going to do exactly what I'm doing here, but for everything. So normalize LeoText. No, whatever. I'll just type it in again. So I have create. I'm creating the vector. Create vector. Or I could just do the norm right here. Huh. Yeah, you know what? I'm already like this. And then find the norm. So what was the LMG norm, R norm? Okay. Norm is equal to the norm 2. So 2 norm, so that's the square root of everything squared added together of the LMG vector. And I'm going to do the same thing, R norm 2 of the R vector. Now, I am going to check if the norm is 0 because I'm going to divide by the values that I get, and I don't want to have a division by 2 error. So I need to check if the norm, so if the LMG norm is not equal. So if it's not equal, I'm going to divide. If it's equal to 0, then I'm going to leave it alone. So if it's not equal to 0, that means that it's okay to divide. And I'm going to divide each of the components. So L mag gradient ijk 1 is now equal to the divided, so it's going to be L mag gradient divided by the norm. And I'll do this for each component of the vector. So this is the third, the second, so XYZ component, and then end if this is not true, then just leave it alone. I need to do this for the R, so this is the LeoText vector. So if R norm is not equal to 0, then I can divide it, so I will. So R, just R I J K 1, and this is the same thing. The X component is equal to R I J K 1 divided by R norm. Oh, and I forgot these. Excellent. Then this is 3 2 2 3, and if perfect. That's not what I want to do. Okay. Excellent. So, dude, stop, please. Okay. So now my normalized vector fields, they're normalized. Check if the norm is 0, and if not, then divide. Me some water. Okay, so this is where I normalize the vector fields. Perfect. I can just add more. Yeah, I could just add more if I wanted to later. I'm not going to do that right now because I only need the gradient, and I only need Leotex. Oh, Omega Leotex. Isn't Omega Leotex? That's just a vector. That's just the magnitude, so that's not. That's not anything. Okay. Divergence toll. I need to add a divergence toll. So dive toll. Ooh. Oh, it's just saying that I'm not using any of these because I'm not. I don't want to delete them yet, because what if I use them later? I'll delete them at the end when I'm done. Okay, everything's normalized. Wait. These are the normalized. Okay, these are the normalized. Awesome. So everything's normalized. Creating the vectors here again. And here is where I'm going to do all my business. Oh, yes, sir. So I did the first condition. The first condition's done. Now, my professor wants me to try the divergence of the gradient and see if it's that. And I wrote a function, this divergence function, and that gives me the divergence. Yes, right here. So I need to create a divergence of LNG. Okay, so I need a divergence of LNG. So it's one of these. So divergence of Leotex magnitude gradient. Now I need to allocate the memory for it. Why am I scrolling down? Stay up here. I need to scroll down here. This on it. So this does all of it at the same time. So allocate divergence, and it's going to be this size, Jmax, Kmax. Now that I've allocated, I can actually calculate it. So divergence of LMG is going to be this right here. This function, and then these are going to be L mag gradient, all of it. The first one, and the same thing here. Second one. The third one here, X, Y, Z, MX. I think I'm gonna replace this. Okay, I think it was safe to replace all. Yeah, that's all I want. Perfect. Yeah. Perfect. Let's go. Oh, it's so much cleaner. Okay, this stands for Leotex magnitude gradient, and these are the X, Y, Z component. X, Y, Z, Z, Z. So this is gonna give me a big. That have the divergence values, and now I need to see this. So right now I don't even need this anymore. So if I know a nested if, let's see, epsilon divergence. Okay, so I'll do the first one. If the divergence of the it says the absolute value. Or is it the magnitude? Because divergence has to do with vectors. Yeah. As divergence of the absolute value of a vector. Yeah, this is divergence. I think it's the absolute value of divergence. Okay, well, the condition 2 that I have here, or what is it? I'll just say this is omega condition. Omega L condition. There, now we're not so ambiguous. Omega L condition. Perfect. So omega L condition. So this is going to be the divergence of latitude and magnitude gradient condition. So, and that condition is that divergence of latitude magnitude gradient of where I am is, well, the absolute value of this is less than or equal to, well, it doesn't matter, right? Tolerance. Just say everything is less than. Then the diverged tolerance. And I like to put everything in parentheses because that's just the way I roll. Dive on G condition. If this, then keep going. Well, I guess that is what we want to do, right? We've got two conditions. And then if the conditions are satisfied, LMG vector and LMG magnitude. LMAG, Louis-Tooke's magnitude. So I need LMG vec. I'll just make it right here. LMG vec. It's equal to LMG 1, LMG 2, LMG 3. Oops. So each component. Okay, cool. So now I have that, which I could just replace this with this. Because that's what they need. Cool. It doesn't like that L core. Did I type something wrong here? L mag. Dimension. Yeah, it's the real. Oh, I'm an idiot. IJK. That's it. Whoopsies. Alright, cool. That's what we want. Okay, so we have the omega condition and then we have the divergence condition. Let me just add the other conditions. So this is the divergence of vertex. That's going to be the same. The absolute value of divergence. I'm going to make this later. Vertex. JK. Seeing if that is less than divergence. Okay, and then I feel like the divergence of omega Leotex would be the same as Leotex, but I guess that's whatever. I need the divergence L divergence, so I need divergence L. So this, but just L, which is just Leotex. Should just be L, right? It's R. I'm an idiot. It's R. R. And why am I using R? It should be L. Oh my gosh, I've already used R. I'll just use the R. Divergence R. This is gonna be R. And I gotta make R here somewhere. Divergence R. Okay. I didn't use any of these. Right? Wait. Is there an error? Why isn't it? Oh, divergence. No. Div R. Div. Oh, I have to allocate it. Div tall. Div R. IJK. Oops. This is one. And that's supposed to be condition. Oh, this is illogical. Div R condition. There we go. Now it's telling me. So I didn't use any of these. None of these. I did not use S. Wait, did I use S? Finding the divergence of vectors. Whoa. Is there? Yeah, these. Oh, I need those.
'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those. 'Cause I need those.
So just make them again real quick. Relate dimension 3 OMG vec, yep, vec and rvec. Okay, perfect. That's perfect. Excellent. So everything's fine now. Now I can start messing with stuff. Well, I have to run it first. Do I even use this? I don't use this. This is the counter. Finding the blank conditions. Make a leave text condition. Divergence. Divergence condition. It's just that these are normalized, and I don't think. Yeah, okay, whatever. I have L and R. I use all L. I hate that. Whatever. Anyways, let me run this, because that's my job. Well, it's not my job. I don't get paid to do this. I know. Pretty cool, huh? I do this for free. Don't spam me. What else? What was I doing? I was gonna run it. Okay. So this should compile and run. Fatal cannot open file. Core line v308. It seems that there was an error compiling it, so let's compile it and see what it says. Terminal. File was not found. File was not found. Oh, this is just what when I opened it last time. What is 1M? Okay. Well, save and then open terminal. Well, let me compile the module first. The module's name is called leotex mod.f. Yeah. Okay, so that's Gucci. Now Fortran.c when I'm working on core line v3. Okay, so it compiled. So now I get to see, so I need leotex mod.o and the core line v3.o. And I want to output, man, I don't know, core line, just core exe. It worked. So core exe, no grid, file data, core line. Oh, I have different data here. I have to change the input file. It reads the input file, and then you see that right here is not matching this number. So this is have to be core 01 500. Okay. Save. Alright, so now let's oh, there's something wrong. There's something wrong. I'm gonna delete every exe file that I can find. And .out file I can find. What does this say? Find core lines.exe. Oh, I mean, yeah. Core line v3. Oh, this is. Ugh, duh. Yes. Now this can't find it. That's supposed to be like that. Okay, perfect. Yeah, that was the issue. I was using Fortran 3 instead of Fortran 8, 2008. So let's try it again. Hey, there we go. $226,000. Ooh, that is a lot. I don't feel like this is correct. Similar sounds. Well, that is a lot. Let me show you what that means. So function and why is it like that? Why is it like that? Core line find yes. Core line and then XYZ. Okay, so alright, so this is the data. Now I need to I'm gonna make a macro. Record macro. I'll record this in here. What is this called? Text ISOs. Text ISO. Right, that's fine. Alright, so I need to make the ISO surface for Leotex 11, make a small rainbow, set levels, max 1. We'll actually flip this. So this will be 0, 1. It's going to be 0.3. And then draw it. And then draw it 0, 7. Okay, I think I got the portion of that is not data. Okay, so these numbers are not correct. Core points, core line, plate, subzip, plate, fun. So this isn't really coding now, is it? Now, what are we looking for here? We're looking for the input file. I think this is 1.2.80, and then this is. I'll just leave that at that. And then let's try again. Let's try that again. $700, 128, 241. So this is 700, 128, and then 241, 241. Okay. Let's try it again. Alright, so that's different. Core line. Dude, what is happening? Hold on, my rabbit's chewing on something. Rabbit, stop. Stop that. Chew on this. He's like eating the bed that he sleeps under when we sleep on it. He's gonna eat through the boards and like it's gonna fall on it. Where was I? Man, oh man. Where is it? Hello? What's happening? Hello, tech plot. Are you you gonna do anything here? I can't move. Is it drawing? What is happening? It's like freaking out. Refreshing screen, refreshing screen. Bro, this thing is tripping. Oh, this thing is not happy. Okay, let's try that again. I'll just open it via open data. This and this. There's no ISO surface. Interesting. Do I have to... Okay, I'll just compile it again, or I'll just let me get added divergence to V3. Okay. Let me just run DNS extract again. Get out of here. DNS, G Fortran, F default, real 8. That's just a flag for the compiler. So every time you see a number, like if someone says 2 times X, that 2 is going to be considered as a real type 8, which is a double. So yeah, so that's what that flag is. I didn't make the code. Well, I kind of worked on it, but I didn't change all the numbers in there. So that kind of takes care of that, of this one. And I'm gonna put it as extract. Oh, .exe, and then run that. Okay, yeah, I needed to run the code again. Yeah, I need to run the code again, so let me cancel this. The plate can go from 109 or 1920, and I'm only doing 700 of it. Okay, so I need to change the input file. So this is going to be 1920. Perfect. And you know what? Since 700 didn't do anything, it wasn't there, I'm gonna do it again. So I don't have to compile it again because the code reads from the. Let's see what this does. Let's see if this actually produces anything. If not, I'll just have to do the whole domain. At this point, yeah, it's just, we have to wait and see. This is all Fortran. That's what this code is. This code is right here. It's pretty long. You see these right here. The way I would do it, I was put D0, and this would say, well, this number is a double. And then if you've ever seen like scientific notation, like 1.2 times 10 to the power of 4, well, that's what this D does. It's 1.3 times 10 to the power of 4. But this D means that it's a double. This number is a double to the power of 4. So that's all it is. I'm gonna exit without saving. I hope it didn't save. I don't know why it didn't tell me not to save. What is happening with Windows? If I open it, it didn't save, right? Why is it doing that? Now I have to save. Okay, finished. My data should be fine. Now I'm going to run my code again. Okay, so we have some points here. I need to see where those points are. Does the... oh, that's not what I want. ABS Fortran. Absolute value. A is... yeah, it's just a number. So it can't be a vector. I can't put a whole vector in there. Can I do absolute value of vector Fortran? Bop, 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 bop. Does it do absolute value? Absolute returns an array containing the absolute values of the elements of array A. So okay, so I can do absolute value of a whole vector, which is probably what I'm going to do because that's what it's said to do. Okay, so all right, so that's done. Let me pop this data in. Boom, boom. Boom. Okay. This needs to be 1-to-1. ISO surface. There's nothing. Where's the ISO surface? You're telling me there's no velocity? What? What's happening? Oh, it's not drawing anything. It's not drawing anything. Mesh. Yes. Edge. Vector. Contour. What? There's nothing. Okay, so let me delete the existing things. So I have 2 data files here. 401500. Well, I'm not really programming, so I guess I'll see you guys later while I debug this. Once I get back to programming, I'll probably come back.